Okay, here on example number 6, our final example for this lesson, we're going to be modeling periodic situations. The situation they're giving us is the voltage supplied by an electrical outlet, which can be represented by a periodic function. The voltage, which is kind of like the pushing force on the electrons, oscillates between negative 120 and 120 volts. So it's actually pushing and then pulling, pushing, then pulling. We call that an alternating current with a frequency of 50 cycles per second. Okay, so if it's achieving 50 cycles of this per second, that means it only takes a 50th of a second to complete one cycle. Write and graph a function for the voltage V as a function of time, t. Okay, so like I said, we would expect one cycle. We don't need to draw out all 50 cycles in 1 second. We can just say that one cycle is going to be completed in a 50th of a second. That will be our period. 1/50th of a second is how long it takes for one complete cycle to go through. Now we know that we want our amplitude to be 120, so that it oscillates between 120 and negative 120, so we'll put that in the front. And then finally, we know that we want one full cycle to be completed at 1/50 for my t value. So when I'm at 1/50, my amplitude at that point, my y value, will be at 0, and my t will be 1/50. So I can put that in 0 for y, 1/50 for t, and then solve for b. Now there is one thing to be careful of, and that's basically what are we thinking about this whole thing needing to equal. So that b times 150, that 150 1/50 seconds is occurring right here. So that is at a full cycle has occurred. Now full cycles are in 2 pi radians. So what we want to do is we want to set this whole thing equal to 2 pi. A different way of saying that is that, like, the way that we figured out our period, the way that we figured out our period and therefore our b value was to look at this kind of relationship between the two. So the period is always 2 pi divided by b. So for example, if we just wanted to go through that route, just looking at that, the period is always 2 pi over b. Well, our period here was 1/50th of a second. And if 1/50th of a second is going to equal 2 pi over b, that means that, b needs to be equal to, we'd multiply by b, multiply by 50, and we would get that b is 100 pi. Okay, so we can put that in. Oops, miswrote it down here. So our equation would be y equals 120 times the sine of 100 pi times t. Okay, if we put that in, we would get our maximum of 120, we'd get our minimum of negative 120, and in addition to that, we would get a full cycle complete every 50th of a second, every 0.02 seconds. Okay, so that would be basically it. So this lesson, as long as you can get onto Desmos and play around with the standard sine functions and just see what happens to them as you change values in them. Just kind of being able to go through and mess around with these a and these b values. Well, for this one, I've already changed the units on the graph too much to see a normal sine function. Either way, getting in here and playing around with these and seeing what happens as we mess around with these, as we shift the values that we are seeing in that A and that B location. Just playing around with that on Desmos should lead you towards a lot more comfort with this topic, as you kind of see what happens when you make things bigger or smaller and start to get those intuitions built up. Okay, so that was it for this lesson. I look forward to seeing you in the next lesson, which is going to be our final lesson on trigonometry.